I'm so glad you found your way here. Perhaps you've had a long day, or maybe you're someone who drifts off best to the quiet wonder of cosmic mysteries rather than counting sheep. Either way, tonight's journey is just for you. You have nothing to do now but rest. Let your mind uncoil, let your breathing slow, and feel your body gently growing heavy and relaxed, as if gravity itself is softening around you. Because tonight, we're not just stargazing, we're drifting through our home galaxy. Tonight's voyage will carry you across the Milky Way. This vast spiral of stars, gas, and dark matter has been turning serenely in space for over 13 billion years. Beneath its gentle glow lie countless secrets, rogue stars flying in the dark, invisible forces holding everything together, and ancient remnants that challenge what we thought we knew. We'll float softly from the galaxy's spiral arms to its hidden central heart, from colossal collisions that shaped it to stars so old they outdate the galaxy itself. Along the way, you'll hear of black holes and stellar nurseries, of ghostly streams and cosmic wonders, all woven into the quiet story of a galaxy that is still growing and changing. As you listen, you may feel curiosity flicker or a sense of awe, and that's okay. Let those feelings come and go like distant stars passing by. There's no need to stay fully alert. You can just let these words wash over you as you drift toward sleep. And just before we begin, a gentle reminder. If these calm explorations help you relax and find peace at the end of the day, consider leaving a like or subscribing to join us again. It helps other sleepy souls discover this little corner of the cosmos too. Now, let's begin our journey through the Milky Way. Imagine yourself under a clear, moonless sky, far from any city lights. Overhead arches a pale river of starlight, the band of the Milky Way. To your eyes, only a few thousand stars are visible, a shimmering sprinkle against the dark. Yet our galaxy holds hundreds of billions of stars in total. Almost all of them are too distant, too faint, or hidden by dust for us to see. The familiar milky band across the sky is just the inner whisper of the Milky Way's true extent, a gentle hint of the immense glowing disk we live inside. In truth, the Milky Way is colossal. From end to end, its spiral disk stretches about 100,000 light-years across. Even a beam of light, the fastest thing in the universe, would take 100 millennia to travel from one edge of the galaxy to the other. Despite this vast width, the galaxy's stellar disk is relatively thin, only a few thousand light-years thick. Picture a great flat disk like a cosmic frisbee, or a delicate pancake of stars. Our own sun lies within this disk, roughly 27,000 light-years from the galactic center. That's about halfway between the core and the edge, placing us in the galactic suburbs. Here, in our quiet neighborhood called the Orion Spur, we float between the Milky Way's major spiral arms in a calm lane of stars that has been a peaceful home for life on Earth. From our vantage point inside the galaxy, uncovering the Milky Way's structure has been a bit like a mouse trying to map the maze it's in. For decades, we thought the Milky Way had 4 prominent arms. Newer surveys suggest there may be only 2 dominant arms, named Perseus and Scutum Centaurus, with several shorter spurs, like our Orion Spur, weaving between them. The reality is complex. The arms are not rigid structures, but languid patterns of stars and gas that twist and branch in ways we're still piecing together. If we could rise above the Milky Way and look down, we'd see a magnificent but somewhat asymmetrical spiral, not a perfectly neat pinwheel. One arm might be longer or brighter, another might split into branches. Our galaxy is a living, layered swirl of stars shaped by forces we are only beginning to understand. Cutting across the center of that spiral is something special, a straight bar of stars. The Milky Way is a barred spiral galaxy, meaning its core isn't just a round bulge of stars, but has an elongated bar structure about 20,000 light-years long. This central bar turns slowly, like a cosmic baton, and its gravity helps channel gas inward and maintain the spiral arms. It acts as a kind of stellar traffic regulator stirring the inner galaxy. Over time, the bar's presence has even shaped the central bulge of the Milky Way. Instead of a simple sphere, the core region is puffed out into a distinctive peanut-like or hourglass shape when viewed from the side. This peanut-shaped bulge, likely formed as the spinning bar buckled the orbits of stars, lifting some above and below the galactic plane. It's a beautiful complexity at the galaxy's heart, a thick cluster of ancient stars, swollen in the middle and narrowing at the ends like a cosmic peanut. Deep in this central bulge, the stars are packed far more closely together than in our region of the galaxy. If you were floating near the Milky Way's core, the night sky would be dazzling with starlight. Thousands of stars might blaze brighter than Sirius does from Earth, and true darkness would never fall. In that crowded stellar metropolis, neighboring stars can be only a fraction of a light year apart, whereas our sun's nearest neighbor is over 4 light years away. The galactic center would never know a fully dark night, illuminated by a perpetual starry radiance. The stars in the Milky Way are not all the same age or color, and you can see this in the galaxy's structure. The spiral arms tend to be lined with young, hot blue stars and glowing nebulae, regions where new stars are forming and lighting up their surroundings. These youthful stars trace the graceful curves of the arms, giving them a bluish-white shimmer. In contrast, the central bulge is populated by much older, cooler stars that shine with a gentle golden light. If you could view the Milky Way from afar, you'd notice this subtle color gradient, a pale golden core that gradually fades into bluish spiral extensions. It's the sign of a galaxy that has been forming stars for eons, with its oldest stars gathered in the center and newer generations sprinkled throughout the disk. Our galaxy's disk itself has layers. We live in what's called the thin disk, a region a few hundred light years thick where stars like the Sun, open star clusters, and nebulae are concentrated. The thin disk is where most new stars form and where the majority of the bright blue stars reside. Above and below this busy plain lies the thick disk, a puffier, more diffuse layer of older stars extending 1,000 light years or more out of the plane. Stars in the thick disk are generally older and have fewer heavy elements since they formed in an earlier epoch of the galaxy. They likely originated when the Milky Way was still young and unsettled, before the disk had fully thinned and organized itself. The thick disk stars orbit the center in more inclined and elliptical paths, giving that component of the galaxy a hazy, halo-like appearance. The Milky Way's disk isn't a single flat sheet of stars, but rather a layered, textured structure, thin and lively in the middle, thicker and quieter as you move above or below the plane. And our Milky Way isn't perfectly flat. Imagine the galaxy's disk as a gigantic spinning plate. Now imagine that plate's edges bent slightly upward on one side and downward on the other. The Milky Way has just such a warp in its outer regions. As we venture toward the edges of the disk, we find that the plane of stars and gas begins to ripple and curve. One side of the galaxy's outskirts is bowed up above the formal mid-plane, and the opposite side is bowed down. This warp is subtle. We don't notice it from our vantage point within, but radio telescopes mapping hydrogen gas have revealed the graceful bend. It's thought that interactions with neighboring satellite galaxies, like the Magellanic Clouds, or the uneven pull of dark matter, might be gently flexing our galaxy's rim. Over time, this warp isn't static. It oscillates slowly as the Milky Way rotates, like a wave traveling around a spinning disk. It turns out the Milky Way has some slight lopsidedness to it as well. The distribution of stars and gas isn't perfectly even on all sides. One half of the disk can be a bit different, slightly more extended or more populated than the other. Even the warp of the disk is not symmetric. It's more pronounced in one direction. These quirks likely trace back to past gravitational encounters. Our galaxy has been tugged and tickled by smaller galaxies in its vicinity, and those interactions have left wrinkles in its structure. Far from ruining the Milky Way's beauty, these asymmetries give it character, a graceful imperfection that tells a story. The galaxy is not a rigid engineered wheel, but an organic, dynamic system shaped by time and history. Encircling the galactic disk and bulge is something even less visible but crucial: the galactic halo. The Milky Way's halo is an enormous, roughly spherical cloud of stars, star clusters, and dark matter that extends well beyond the bright disk, perhaps hundreds of thousands of light years into space. By day we see the blue sky, and by night the stars, but beyond the farthest star you can see, our galaxy still extends into the darkness with this halo. In this halo drift, some of the oldest members of the Milky Way, ancient stars and globular clusters that formed when the galaxy and the universe was young. The halo's stars are sparse, spread across a tremendous volume, and many follow long tilted orbits that carry them high above the galaxy and far below it. Among the treasures of the halo are the globular clusters. More than 150 of them have been found so far. A globular cluster is like a ball of stars containing hundreds of thousands of stars packed densely together, all born around the same time long, long ago. These clusters orbit the center of the Milky Way like bees circling a hive. They are relics of the early galaxy, and perhaps of smaller proto-galaxies that merged with ours, with ages of 12 billion years or more. The stars in globular clusters are extremely old and metal-poor. In astronomy, metals means any element heavier than helium, meaning they formed before many heavy elements existed in the cosmos. If you could approach a globular cluster, you'd see an incredible sight: a swarm of ancient suns crowding the sky. But from our vantage point, they appear as faint, fuzzy glows in telescopes sprinkled around the Milky Way's outskirts. These globular clusters serve as living fossils of the galaxy's youth, preserving clues to how our Milky Way grew. They hang in the halo, quietly tracing out the mass of the galaxy with their orbits. Perhaps most importantly, the halo is also where most of the Milky Way's mass resides, in a form we cannot see. Astronomers are confident that an enormous amount of dark matter surrounds our galaxy, outweighing all the stars and gas by several times. This dark matter forms a massive, invisible halo extending far beyond the visible stars and clusters. We only know it's there because of its gravitational pull. It tugs on the outer stars and globular clusters, keeping them orbiting faster than they otherwise would. Without the dark matter halo, the Milky Way's outer regions would not rotate as they do. The stars at the edge would drift off into space rather than remain bound to the galaxy. So as we picture the Milky Way, remember that what we see, the stars, the glowing band in the sky, the clusters and nebulae, is only a small portion of it. The true extent of our galaxy is an enormous dark halo full of mystery, holding everything together in its quiet gravitational grip. Scientists are continually refining this galactic map. The European Gaia spacecraft, for example, is in the midst of charting over 1 billion stars with exquisite precision. With its data, astronomers have discovered long streams of stars, the remnants of ancient mergers, mapped the subtle warp and wiggle of the disk, and measured the distances and motions of stars all across the sky. Each new observation turns that hazy band of the Milky Way into a sharper, richer portrait, revealing our galaxy as a truly living system, full of structure and surprises. Nothing in the galaxy is truly still. Our own solar system is whirling around the galactic center at an astonishing speed, roughly 230 kilometers per second, over 800,000 kilometers per hour. Even at that breakneck pace, the Milky Way is so vast that it takes about 225 million years for the Sun to complete a single orbit. Astronomers call this immense cycle a galactic year. In the 4.6 billion years since the Sun and planets formed, we've only made around 20 trips around the center of the galaxy. Think of that. When the first dinosaurs walked the Earth, we were in a very different part of the Milky Way, roughly one galactic season ago. Over the course of a single galactic year, continents drift and species rise and fall. It's a timescale so grand that our human calendars shrink to insignificance. Yet, despite moving so fast through space, we don't feel it at all. As you lie here, the Earth is quietly turning on its axis, the Moon is gliding around the Earth, and together our whole solar system is sweeping along on this galactic journey. Everything is in motion, quietly, slowly, endlessly. The stars, including our Sun, orbit the galactic center under the pull of gravity, and the entire Milky Way rotates like a giant, graceful pinwheel. Near the center, where gravity is strongest, stars complete their orbits in mere millions of years. Out here in the galaxy's suburbs, our Sun ambles along more leisurely, taking hundreds of millions of years per circuit. But amazingly, because of the unseen mass of dark matter holding the galaxy together, even stars far from the center orbit at surprisingly high speeds instead of drifting away. The Milky Way turns almost like a solid disk, with stars in the outer regions moving faster than expected if only visible matter existed, one of the first clues to the existence of our galaxy's dark halo. It's a cosmic dance maintained by gravity's hidden hand. Our solar system's position in the galaxy happens to be rather fortunate. We orbit in a relatively calm region and at a speed that roughly keeps pace with the spiral pattern. This means we don't plunge repeatedly through crowded spiral arms or the hazardous environs near the core. Instead, we circle in a quieter zone, nestled between major arms. Some astronomers think this has given life on Earth a steadier environment. Fewer nearby supernova shocks, less intense radiation. A kind of cosmic Goldilocks zone where conditions are just right. Here in this stable orbit, our Sun has circled the center comfortably, and life had time to develop on our planet with long stretches of relative calm. As we orbit, the Sun also bobbles gently up and down through the plane of the galaxy. Every few tens of millions of years, our solar system drifts a bit above the galactic midplane and then back down through it, like a cork bobbing slowly on a vast, dark ocean. Right now, the Sun is just slightly above the central plane, moving upward, but eventually it will be pulled back down. This oscillation is subtle and we never notice it day to day, but over geological time, it's another rhythm of our journey. Some have even speculated that these bobs might disturb clouds of comets at the fringes of the solar system or correspond with cycles of mass extinctions on Earth. The evidence for that is unclear, but the image is peaceful. Our Sun swaying softly as it travels, like a traveler riding gentle swells in the galactic sea. Picture it. Even as you rest now, our entire solar system is in motion through the Milky Way, carrying you and everything you know on a grand carousel ride among the stars. It's a smooth and steady ride that has gone on for billions of years. We are moving through a vast, dark sky, but we are securely bound within our galaxy's embrace. This motion has carried us around the galaxy countless times before, and it will continue long after we're gone. A gentle cosmic lullaby of motion that rocks us ever so slightly as we sleep. Our Milky Way may feel like a stable, solitary haven in the cosmos, but in truth, it is the product of many mergers and unions over cosmic time. Over billions of years, our galaxy has absorbed and cannibalized numerous smaller galaxies that wandered too close. These galactic collisions are usually not violent crashes of stars. Space is so spacious that direct stellar collisions are extremely rare, but rather gradual gravitational minglings. The larger Milky Way draws in the smaller system. Its stars and gas are pulled into long streams and eventually become part of the Milky Way's own halo or disk. Even now, this process continues. A small companion called the Sagittarius Dwarf Galaxy is currently being torn apart by our galaxy's gravity. Its stars are streaming out in a long ribbon that wraps around the Milky Way, adding their light to our halo, and the Sagittarius Dwarf is just one example. Astronomers suspect the Milky Way has devoured dozens of such dwarf galaxies in the past. The evidence lies written in the sky: faint tidal streams of stars arcing around the galaxy, remnants of long-ago galaxies that were unraveled and woven into our own. By studying these stellar streams and the motions of stars in the halo, scientists have identified specific ancient mergers. For instance, a major collision about 9 to 10 billion years ago, often called the Gaia Enceladus event, that brought in a huge population of stars and helped shape the early Milky Way. In a sense, our galaxy is a patchwork quilt stitched together from the remains of many smaller protogalaxies. Some of the stars now in the Milky Way originated outside it, born in those smaller galaxies before they were assimilated. In fact, a few stars in our halo appear to be almost as old as the universe itself, meaning they formed in primordial mini-galaxies that later merged into the young Milky Way. These stars have traveled through space for over 13 billion years and eventually found themselves as part of our halo. They betray their exotic origins through their composition and movements. Astronomers sometimes call them stellar immigrants. They often have extremely low levels of heavy elements, since they were born before many supernovae enriched the cosmos, and they move in unusual orbits compared to native Milky Way stars. By examining the chemical fingerprint of a star, the pattern of elements in its light, scientists can tell whether it likely was born in our galaxy or in another that merged with ours. In this way, chemistry and orbital dynamics let us read the Milky Way's family tree. It's as if the galaxy carries old memories of long-ago collisions in the very makeup and paths of its stars. There's even a star in the halo often cited as one of the oldest known. It contains almost no elements heavier than helium, indicating it formed shortly after the Big Bang. It shines now as a living fossil, a quiet red ember nearly as old as the universe itself. A star that has seen the entire saga of our galaxy unfold around it. Despite being ancient, the Milky Way is not a finished work. It's still growing and changing today. Far out in intergalactic space, tendrils of gas from the cosmic web continue to funnel down into our galaxy's halo, providing raw fuel for future generations of stars. The Milky Way acts like a gravitational well, pulling in anything that comes too near. In addition to the Sagittarius dwarf, there are other dwarf galaxies in our vicinity slowly being drawn in. The large and small Magellanic Clouds, two bright satellite galaxies visible from Earth's southern hemisphere, are orbiting our Milky Way and may be on their first approach toward us. New evidence suggests these irregular little galaxies might only recently have been captured by our gravity. As they sweep by, their influence has been tugging on the Milky Way's outer disk, possibly contributing to the warp we observe. A stream of hydrogen gas known as the Magellanic Stream stretches behind them for hundreds of thousands of light years, like a cosmic ribbon trailing these dwarf galaxies. This stream is essentially material being siphoned off by the Milky Way's pull. In time, some of that gas will likely rain down onto the Milky Way's disk, fueling the birth of new stars. Piece by piece, cloud by cloud, the Milky Way continues to gather matter from its surroundings, growing heavier and larger even now. Our galaxy is also part of a small community of galaxies bound together by gravity, a collection known as the Local Group. Along with the Milky Way and its retinue of dwarf companions, the Local Group includes the Andromeda Galaxy, a spiral galaxy a bit larger than our own, and dozens of even smaller galaxies scattered in the region. All these galaxies are drifting through space together, loosely bound by their mutual gravity like a family of cosmic islands. They are not flying apart with the expansion of the universe because their gravity holds them together. In the grand scheme, Our Milky Way and Andromeda are the two heavyweight members of this group, and they are on a slow collision course with each other. Far beyond the stars of our night sky, the Andromeda Galaxy, also called M31, lies about 2.5 million light-years away. A hazy spindle of light if you know where to look on a dark night. Andromeda is moving steadily toward us, drawn by our shared gravitational center. In roughly 4 to 5 billion years, the Milky Way and Andromeda will begin to merge. It's not something to fear. By then, the Sun and Earth will be in very different stages. And even when galaxies collide, individual stars almost never hit each other due to the vast distances between them. Instead, the two galaxies will pass through one another like cosmic ghosts, their shapes warping under gravity's embrace. Our beautiful spiral arms may be smeared out into long tidal tails stretching into space. Over a few billion years of gravitational dances and mergers, the two will eventually settle into one combined system, likely a large elliptical galaxy with a more rounded shape, since the collision will scramble the neat spiral patterns. It will be a slow, majestic merging, truly a gentle cosmic dance leading to the birth of a new galaxy from two old ones. When the Milky Way and Andromeda finally fuse, their central black holes may spiral together and unite, and the stars from both galaxies will intermingle in a new, blended family. Future night skies, for any beings that might exist then, will look very different. Perhaps a soft, diffuse glow of an elliptical galaxy instead of the band of the Milky Way. This event is far in the future, but it reminds us that even galaxies live evolving lives. They are born small, grow through mergers, develop arms and bars, and eventually may collide to begin again in a new form. Even galaxies are not eternal. They change and reinvent themselves on billion-year timescales. Our Milky Way has already collided and merged with others in the past, and it will do so again in the future. In the grand ballet of the cosmos, endings often blend into new beginnings. One day the Milky Way will be gone in its current form, its stars rearranged into a new galaxy. But that transformation will be the start of another chapter in the universe's story. For now, though, we reside in the Milky Way's peaceful middle age, enjoying the calm and splendor of a spiral galaxy that still has many adventures ahead. Within our galaxy's grand structure, countless smaller dramas are unfolding. The birth and death of stars, the formation of planets, and the continuous recycling of cosmic material. In the dark patches of the Milky Way's arms, where starlight is obscured, lie immense cold clouds of gas and dust. These are molecular clouds, some spanning hundreds of light years, and they are the cradles of new stars. Inside these frigid, dense clouds, chilled to only a few degrees above absolute zero, the pull of gravity works slowly, drawing clumps of material together. For long ages, nothing may happen. The cloud drifts quietly, like a silent fog in space. But perhaps a gentle nudge occurs, two clouds collide, or a ripple from a passing spiral arm compresses the gas just enough. When enough gas piles up in one region of the cloud, gravity takes over, and that region begins to collapse inward. A star is preparing to be born. As the gas collapses, it fragments into smaller pockets, each pocket destined to become a new star or star system. In the center of a collapsing clump, matter falls into a tight ball and begins to heat up. Around it, a flat disk of leftover gas and dust forms, spinning faster as it shrinks, much like a skater spinning faster when pulling in their arms. Within that disk, countless tiny dust grains collide and stick, gradually building up into pebbles and rocks, then into larger planetesimals, and eventually into full-fledged planets and moons. But at the heart of the disk is where the real drama unfolds, the growing protostar. Over tens of thousands of years, the pressure and temperature at its core climb higher and higher. When they reach a critical point, hydrogen atoms begin to fuse into helium, releasing a burst of energy. At that moment, a new star ignites, shining its first light into the cosmos. These infant stars often announce themselves dramatically. They can blow away the cocoon of dust that hid them, allowing their light to escape. In regions like the Orion Nebula, a stellar nursery relatively close by, we see glowing clouds where dozens of stars are being born together. The youngest stars are often blindingly bright and blue, pouring out intense ultraviolet radiation that causes the surrounding gas to fluoresce in beautiful colors. We call these regions stellar nurseries, and they adorn the spiral arms with subtle luminous patches like blossoms on a cosmic vine. Every star, including our sun, was born in such a place long ago. For a short time, a few million years, which is brief in galactic terms, the cluster of sibling stars stays near its birth cloud, bound loosely together. But gradually, they drift apart, scattering into the galaxy as the gravitational pull of the wider Milky Way disrupts their youthful family. Star formation in the Milky Way was once much more vigorous than it is now. Billions of years ago, when the galaxy was younger and rich with untapped gas, it may have birthed stars at a furious rate. Today, the Milky Way's star birth has calmed to a gentle pace. Astronomers estimate that our galaxy forms only a few new stars per year on average. Some years might see a bit more, some a bit less. We still have enormous reservoirs of gas, but much of it is spread thin, warmed, or held stable by magnetic fields, not as quick to collapse into stars as in ages past. The galaxy has matured. Like a fiery youth settling into adulthood, it now creates new stars at a more relaxed rate. This doesn't mean the Milky Way is anywhere near the end of its star-forming days. Far from it. There's enough gas left to keep making stars for a long time. But we live in a quieter chapter of our galaxy's life, a golden middle age where the frantic fireworks of youth have subsided into a steady, enduring glow. Not every pocket of gas gets to become a star, however. Scattered throughout the galaxy are enormous clouds that seem ripe for star formation, but have not ignited any stars yet. Some are too diffuse and spread out. Others might be stabilized by magnetic fields or turbulence inside them. These dark, starless clouds float as cold, silent reservoirs of possibility, rich in hydrogen molecules but untouched by starlight. They may persist for millions of years as unlit fog banks drifting through the galactic disk. Perhaps one day a passing supernova shock or the tidal influence of a spiral arm will give one of these clouds the nudge it needs to start collapsing. Or perhaps they'll eventually disperse without ever forming a star, their material incorporated into other clouds or accreted quietly by the galaxy's halo. In these quiet clouds, the Milky Way holds its breath, a reminder that even in a galaxy full of brilliance, there are pockets of deep potential awaiting the right moment to shine. While stars are being born in some parts of the galaxy, elsewhere, older stars are reaching the ends of their lives. Massive stars, those many times heavier than the sun, live fast and die young. After burning brightly for only a few million years, they exhaust their nuclear fuel, and the balance that holds them up falters. In that final moment, the star's core collapses and then explosively rebounds, blowing the star apart in a cataclysmic supernova. A supernova can briefly outshine all the billions of other stars in the galaxy. When such a star detonates, it flings its outer layers into space, creating an expanding shell of gas enriched with heavy elements like oxygen, carbon, iron, and more, the elements that will become the building blocks of planets and life. These explosions are not just spectacular ends. They are also creative acts. The shock waves from supernovae surge through the interstellar medium, compressing nearby clouds and possibly triggering new rounds of star formation, like a cosmic gardener scattering seeds. Moreover, the debris from the supernova carries freshly forged elements and scatters them far and wide. Over time, generation after generation of stars enriches the galaxy. Early stars were born with almost pure hydrogen and helium. Each subsequent generation added heavier elements, carbon, nitrogen, iron, gold, and so on, synthesized in stellar cores or during supernova and then strewn across space. Dying low-mass stars, like red giants, gently puff out their outer layers as beautiful planetary nebulae, contributing elements like carbon and nitrogen to the galactic clouds. Massive stars spread elements more violently in supernova blasts. This stellar alchemy is the reason we exist. The calcium in your bones, the iron in your blood, the oxygen you breathe were all forged in stars that lived and died long before the Earth formed. The Milky Way is essentially a giant recycling system. Stars form, shine, and eventually return much of their material to the galaxy's reservoirs, where new stars and planets will one day incorporate those elements. Every atom in our bodies has been part of this cosmic cycle, born in a star, scattered through space, gathered into new forms, and now temporarily part of you. In a very literal way, the galaxy is our ancestor. We are made of its stardust, the ashes of ancient suns. The ongoing cycle has other interesting facets. What goes up sometimes comes back down. When many massive stars go supernova in the same region, for example in a big star cluster, their combined fury can create a superbubble of hot gas that bursts out of the disk. We see evidence of these enormous cavities and galactic chimneys in X-ray maps of the Milky Way, regions where the interstellar gas has been blown away, leaving hot, thin plasma. These superbubbles punch through the galaxy's disk and vent hot gas into the halo. Eventually, as that gas cools and slows, much of it drifts back down, raining into the disk again. Astronomers call this circulating flow a galactic fountain, hot plasma streaming upward, then condensing and sprinkling back into the galaxy's gravitational well. It's another way the Milky Way regulates itself, dispersing energy and enriched gas far and wide, then reclaiming material for new stars. It's as though the galaxy takes deep breaths, exhaling after clusters of supernovae, inhaling fresh fuel to continue the cycle of creation. Just as star birth leads naturally to star death leads naturally to star birth, an elegant loop of renewal. And accompanying nearly every new star that forms is the potential for planets. In the spinning disks around newborn stars, dust grains stick together and grow into rocks. Rocks gather into planetesimals and eventually into full-fledged planets. Planets, it turns out, are very common. We've confirmed over 5,000 exoplanets, planets around other stars, in our Milky Way, and that's just from surveying small patches of sky for a few decades. From these findings, scientists infer that most stars likely have at least one planet, and many have entire systems of them. There could be hundreds of billions of planets in our galaxy. These worlds come in astonishing variety. Gas giants larger than Jupiter, scorching hot Jupiters that hug close to their stars, rocky super-Earths bigger than our planet, ice-covered moons around faraway gas giants, and many other configurations that have no exact counterpart in our own solar system. Some planets orbit so near their suns that a year lasts only a few days and their atmospheres are constantly scorched. Others circle in the frigid outskirts, taking thousands of years to complete an orbit, or even dance around two suns at once. There are planets in environments we once thought impossible. And not every planet remains bound to a star. Astronomers suspect there may be billions of rogue planets wandering the galaxy independently, either flung out of their native systems or formed alone in the depths of space. Cold and dark, these free-floating worlds are hard to detect, but they too are part of the Milky Way's planetary menagerie. The Milky Way is not only teeming with stars, it is teeming with worlds, each one a potential stage for unique phenomena and perhaps even life. Our own solar system is one example of how cosmic ingredients can come together to form not just a star, but a nurturing home for life. And it wasn't an isolated miracle. the galaxy provided the raw materials. The water on Earth likely originated as ice grains in the primordial solar nebula or was delivered by comets that formed in the outer reaches, water that condensed from gas enriched by earlier stars. Organic molecules, including simple amino acids and complex carbon chains, have been detected in interstellar clouds and even in the protoplanetary disks of forming solar systems. The Milky Way effectively sowed the seeds of life by distributing these molecules across space. When Earth was young, it inherited carbon compounds, water, and other essentials from the cloud that formed our sun and planets. And the same is surely happening in countless other nascent solar systems across the galaxy. Each time a new star and its planets emerge from a molecular cloud, they carry with them a chemistry set of possibilities, the same ingredients that on Earth led to living cells. We don't know how common life is in the galaxy, or if any of those billions of planets host beings who gaze up at their sky and wonder as we do. But the Milky Way has provided the conditions and the building blocks for life in many places. In that sense, life on Earth is a product of our galaxy, a way for the cosmos to know itself. We may or may not be alone, but we are certainly not isolated. We are part of a vast galactic ecosystem, connected by the flow of atoms and energy. Stars rarely form in isolation, as we noted. They usually come in clusters from the same cloud. For a time, these newborn stars drift together, loosely bound by gravity, but over time, even these clusters gradually disperse. Tidal forces from the Milky Way pull at them. Close encounters between cluster members can fling some out, and the cluster's collective gravity weakens as the stars wander off one by one. After a few 100 million years, most open clusters, loose clusters of young stars, have unraveled. Their stars join the general stellar population of the galaxy, each continuing its journey alone, or perhaps with its own planets or companion stars. Our sun almost certainly began its life in such a cluster. It had siblings, perhaps 1,000 of them, born from the same cloud around 4.6 billion years ago. In those early millennia, our sun would have shared the sky with many bright nearby stars, its brother and sister stars lighting up its heavens. But as the cluster orbited the galaxy, it gradually dissolved. Today, those siblings are scattered all across the Milky Way. Astronomers are searching for them by looking for stars with the same age, motion, and chemical makeup as the sun, essentially trying to identify our sun's long-lost family. A few candidates have turned up, but most of the sun's siblings have wandered too far to pick out. Still, it's a remarkable thought. Somewhere out there in the galaxy, there are stars that were born right alongside our sun, now perhaps shining tranquilly in other parts of the Milky Way, distant kin amid the sea of stars. In the Milky Way, even companionship can be temporary. Many stars do live in pairs or multiples, orbiting each other in gravitational embrace. But even these bonds can be broken by the galaxy's gravitational churn. If a binary star system passes too close to the central black hole or into the dense hub of a globular cluster, tidal forces can disrupt it. One star might be snatched away or significantly slowed, while the other is flung out at tremendous speed. Occasionally, such interactions, or a powerful supernova explosion in a binary system, will eject a star entirely from the galaxy's grasp. These hypervelocity stars are rare, but they exist. Solitary suns racing out of the Milky Way, never to return. Some have been accelerated by the central black hole. A binary star wanders too near. One star gets swallowed or severely deflected by the black hole, and its partner is slingshotted into intergalactic space. Others might be victims of three-star pileups and clusters, or the result of one star in a binary going supernova and kicking its companion away like a recoil. Whatever the cause, these rogue stars travel the darkness between galaxies, destined to wander the cosmos alone. They carry with them the memory of our galaxy's gravity, even as they escape it. It's a quiet reminder that not everything that belongs to the Milky Way remains forever. A few flickering lights slip into the night like fireflies drifting from a meadow into the woods. Despite such dramatic exceptions, the vast majority of stars will live out their lives within the Milky Way, contributing their material back to it and continuing the great cycle. The galaxy's billions of stars orbit peacefully, generation after generation, painting the sky with their collective light. Over billions of years, the Milky Way has maintained this equilibrium, forging new stars from old debris, mixing elements and energy, and gradually evolving in form as it does so. Amid this grand ballet of creation and destruction, here we are, living on a small planet around an unassuming star, at just the right time in the galaxy's life to have both an abundance of elements and a stable environment to thrive in. We are, quite literally, made of stardust. The galaxy's past lives are in our bones and blood. In a very real way, we are the Milky Way, contemplating itself. As you breathe softly, remember that the oxygen filling your lungs was brewed in ancient stars. The gentle warmth in your body is powered by the sun, which itself is a child of this galaxy. We are threads in this cosmic tapestry, connected to the stars overhead in the most profound of ways. If we step back from individual stars and look at the galaxy as a whole, we find that the Milky Way has many facets beyond the visible stars. It hums with forms of energy and signals that our eyes alone cannot detect. In radio waves, for example, the Milky Way's outline becomes clear. Radio telescopes can see through the dust to map the cold hydrogen gas tracing the spiral arms and the warp of the disk. They also pick up the steady whisper of electrons spiraling along magnetic field lines and strange repetitive bursts from magnetized neutron stars. In infrared light, we can peer into dusty nebulae and the crowded galactic center, seeing the heat of stars embedded in clouds and the glow of warm dust that visible light cannot penetrate. The galaxy shines in ultraviolet from hot young stars and in faint X-rays from million-degree gas spread through the halo and from the remnants of supernova explosions. High above the disk, towering gamma-ray bubbles, discovered by the Fermi Space Telescope, loom over the galactic center, each one tens of thousands of light-years tall, hinting at some colossal outburst from the core in the not-too-distant past. In essence, the Milky Way speaks in many frequencies, a whole electromagnetic symphony that we're only beginning to fully appreciate with modern observatories. Threading through all of this is an invisible but influential structure, the galaxy's magnetic field. Though far weaker than a typical fridge magnet, over galactic distances, this field subtly guides charged particles and affects how gas clumps and moves. It runs along the spiral arms and arches into the halo, shaping itself around exploding bubbles and strong stellar winds. We can detect its presence by the way it polarizes light from distant stars. Tiny interstellar dust grains align with the magnetic field and cause starlight passing through to become slightly polarized. We also see the magnetic field's effects in how cosmic rays propagate. These charged particles zigzag along field lines, taking twisted paths across the galaxy. The Milky Way's magnetic field is like a hidden framework, a ghostly scaffold of energy woven through the space between stars. At the very center of the Milky Way lies one of its most profound and fascinating features, a place of extreme gravity and mystery. In the direction of the constellation Sagittarius, nestled deep in the galaxy's core, resides a supermassive black hole known as Sagittarius A star, pronounced Sagittarius A star. This black hole is about 4 million times the mass of our Sun, yet all of that mass is confined to a region of space smaller than our solar system. We cannot see the black hole itself, since not even light can escape it. But we know it's there by its gravitational effects on nearby stars and gas. Over the past few decades, Astronomers have watched stars near the galactic center whipping around an invisible point at astonishing speeds. One star, called S2, accelerated to a significant fraction of the speed of light as it swung around the unseen mass, completing its orbit in just 16 years. Only an immensely massive, compact object could cause such furious motion, and a black hole fits the bill. Most of the time, Sagittarius A star is surprisingly quiet. If you pointed a normal telescope at the galactic center, you wouldn't see anything obvious betraying a black hole. But occasionally, it makes its presence known. When a cloud of gas or an unlucky star ventures too close, the black hole's gravity snags some of that material. As the captured gas spirals inward, like water swirling down a drain, it heats up and flashes in X-rays and radio waves before vanishing beyond the event horizon. We've built specialized observatories to monitor these flickers, catching brief X-ray flares that tell us something is being devoured by the dark heart of the galaxy. In 2022, an international team using the Event Horizon Telescope, a network of radio dishes spanning the globe, released the first-ever image of the region immediately around our black hole. It revealed a faint glowing ring of superheated gas surrounding a dark shadow. That shadow is the imprint of the black hole itself, Sagittarius A star, on the radiant swirl of material around it. It was a stunning confirmation that, indeed, a sleeping Leviathan lurks at our galaxy's core. Long ago, Sagittarius A star may not have been so quiescent. If, in the distant past, large amounts of gas flowed into the black hole, the Milky Way's center might have blazed as a quasar, a brilliant beacon of energy that could outshine the entire galaxy. While that era is over, we see echoes of it in the giant gamma-ray bubbles above and below the plane. Those bubbles suggest that a few million years back, our central black hole, or perhaps rapid star formation near the core, unleashed a tremendous burst of energy that blew hot gas outward in vast lobes. Now those lobes glow softly in high-energy light, like afterglow embers suspended above and below the galactic center. Today, however, our galaxy's heart is relatively calm. The supermassive black hole sleeps, stirring only occasionally. It remains the gravitational hub of the Milky Way, quietly choreographing the orbits of stars and gas near the core in a complex, relentless dance. Elsewhere in the galaxy, other extreme phenomena abound. Consider pulsars, the spinning neutron stars left behind when massive stars explode. A neutron star is the ultra-dense core of a star, squeezed into a ball perhaps only 20 kilometers across. Pulsars are neutron stars that rotate rapidly, sometimes hundreds of spins per second, and emit beams of radiation from their magnetic poles. As they spin, those beams sweep across space like the lights of a lighthouse. If Earth lies in the path of the beams, we detect a regular pulsing signal, flashes of radio waves or light arriving with clockwork precision. Across the Milky Way, hundreds of pulsars flash in this way, like tiny cosmic metronomes. Some are so regular that they rival atomic clocks in stability. Astronomers use these pulsar ticks to probe all kinds of cosmic phenomena, to measure distances, to test theories of gravity, and even to search for the gentle tremors of far-off gravitational waves. Imagine a city filled with lighthouse beacons turning on and off in perfect rhythm. That's our galaxy and pulsar signals, a hidden grid of cosmic clocks silently keeping time amidst the stars. The Milky Way is also filled with cosmic rays, high-energy particles, mostly protons and atomic nuclei, that zip through space at nearly light speed. Many of these originate from supernova shock waves in our galaxy. The death throes of stars accelerate particles to enormous energies and fling them out into space. These particles then wander the galaxy, guided and deflected by magnetic fields. Every second, countless cosmic ray particles are passing through your body. We're completely unaware of them, They're invisible and mostly harmless at the doses we receive on Earth's surface. Our atmosphere shields us from many of them. But now and then, one strikes an air molecule high above and creates a shower of secondary particles that can be detected by sensitive instruments. Cosmic rays are like a drizzle of fast-moving atoms that permeates the galaxy. To astrophysicists, they carry messages. Their energy and composition tell us about exotic events like supernova, pulsar winds, or even distant galaxies' explosions. But to us on a quiet night, they are just another part of the galaxy's subtle background, an unseen rain of particles whispering through our world. Even more elusive are the neutrinos. These ghostly subatomic particles are produced in vast numbers by nuclear reactions in stars, like those in our Sun, and especially by supernova explosions. Neutrinos hardly interact with normal matter. Trillions of them stream through you each second without leaving a trace. When a massive star's core collapses in a supernova, a huge pulse of neutrinos erupts from the dying star, carrying away much of the energy. These neutrinos fly out in all directions, passing through the star's outer layers and everything else, as if it were empty space. In 1987, when a star went supernova in a nearby dwarf galaxy, neutrino detectors on Earth registered a few dozen neutrinos, a gentle tap on our instruments that announced the star's death even before the light from the explosion reached us. Within the Milky Way, if a supernova occurred, observatories would see a burst of neutrinos heralding it. The galaxy is quietly filled with these ghost particles from all the fusion in stars and past stellar deaths. We don't notice them in daily life, but they are there. Phantom messengers traveling straight through planets, stars, and us. Our galaxy also serves as a gigantic listening post for the universe's most subtle murmurs, gravitational waves. These ripples in space-time are produced by cataclysmic events like the merging of black holes or neutron stars. When such an event happens in a distant galaxy, it sends out waves that stretch and squeeze space itself. These waves move outward at the speed of light, eventually passing through the Milky Way. They are extremely faint by the time they reach us, making them incredibly hard to detect. But with instruments like LIGO and Virgo on Earth, scientists have begun to capture these whispers. We've heard the fleeting chirp of two black holes colliding 1 billion light-years away, and the shudder of neutron stars merging and unleashing heavy elements into space. The Milky Way, of course, is transparent to gravitational waves. They ripple through the stars and planets without distortion. Even as you rest, space-time around you is gently vibrating with ancient echoes of far-off collisions. You can't feel these distortions. They're far too small, fractions of an atomic diameter. But it's comforting to know that our galaxy is part of a cosmic network, connected by these ghostly quivers. In fact, astronomers are now using pulsars distributed across the Milky Way as a kind of galactic-scale gravitational wave detector. By checking if the pulses from many pulsars fluctuate in sync, they hope to sense the slow undulations of space produced by supermassive black holes merging in remote galaxies. It's poetic, using our galaxy's own stars as instruments to detect the subtle vibrations of the universe at large. Even as you lie here, space itself is passing gentle waves through you, an imperceptible lullaby from the distant universe. From the calmest phenomena to the most violent, the Milky Way contains multitudes. There are regions of utter darkness and quiet, and regions blazing with energy and motion. There are stars being born and stars dying, matter falling into black holes and matter streaming away in winds and jets. And yet, to our eyes, the overall impression of our galaxy is one of serene permanence. The stars wheel overhead nightly in a slow, stately progression. The Milky Way's band is a constant, comforting presence across generations. Only when we look deeper with our instruments do we perceive the bustling, dynamic ecosystem behind that calm band of light. This is our home galaxy, a place of both tranquility and tremendous activity, a vast and ancient system that still finds ways to be lively and surprising. And as complex as it is, the Milky Way holds special significance for us. It is the backdrop to all of human history, the canvas of the night sky that guided and inspired our ancestors, and the source of the atoms that make up our bodies. Now the stars begin to dim behind your thoughts. Your eyelids are growing heavy, and the night is softening around you. We have explored so much, and it's okay to let those images blur and simply feel the vast peace of our galaxy. We've now drifted through 200 quiet truths about our Milky Way, from the gentle warp of its starlit disk to the farthest lonely halo star, from brilliant newborn suns in their nebular cradles to the ancient stellar remnants quietly glowing in the dark, from swirling dust and gas to light and shadow and everything in between. We have wandered widely on this cosmic journey. You've traveled in your mind through spiral arms and across the galactic plane, ventured into the secretive central core and back out into the whispering halo. You've danced among star clusters, lingered in nebulae, and gazed toward the galaxy's heart glowing softly behind distant dust. Through it all, remember that you are a part of this galaxy, not just a spectator on Earth, but an active participant in the Milky Way story. The iron in your blood was forged in the heart of a star billions of years ago, and the calcium in your bones was cast in an ancient supernova's fury. The very air you breathe, rich in oxygen, was created by red giant stars and dispersed by stellar winds. Your atoms, your existence, are tied intimately to the stars above. You belong here. You are made of this cosmic matter, born of the Milky Way's long history of creation and destruction. In a very real sense, the galaxy is within you, and you are within it, a small, warm spark of awareness in an ocean of stars. Tonight, as you prepare to sleep, the Milky Way continues its slow, quiet turning. Even now, somewhere out there, a new star ignites, while elsewhere, an old star yields to darkness. Planets are coalescing in dusty rings around newborn suns. Perhaps life is taking root on some distant world under the glow of an alien sky. The great engines of the galaxy, stars, nebulae, black holes, carry on in their majestic rhythms, and our entire solar system, with you in it, is gliding effortlessly through that vast cosmic night, secure in the galaxy's embrace. You are floating in a spiral arm of a calm, radiant galactic sea, exactly where you need to be. For thousands of years, people have looked up at the Milky Way in wonder, seeing a river of spilled milk, a path of souls, a bridge of birds carrying lovers, a backbone holding up the sky. It has always been a source of mystery and comfort. And now you know that misty band is home, the combined light of billions of distant suns, and the source of everything that makes you you. Under that gentle glow, you can feel connected to something enduring and grand. There is nothing more you need to do right now. Feel the gentle tug of sleep drawing you, as steady and sure as gravity. You can let your thoughts grow soft and distant, like starlight traveling for eons before coming to rest. The Milky Way watches over you from above, a comforting presence in the night. You are home in this universe, cradled by the stars. So breathe deeply and allow yourself to drift off, knowing that you are part of something vast and beautiful. The galaxy will continue to turn, carrying you peacefully along on this cosmic journey. Rest now, dear listener. Let sleep enfold you like the dark between the stars, calm and eternal. Dream softly of starry skies and gentle nights. Good night.